Alright, so welcome back to the second part in my Create Rank Portfolio series, and today we're going to be creating a prime number identifier. So let's start off by importing a package, the java.util.scanner package, and then let's write our main method. Alright, once we've got that, let's create scanner equals n.next. Scanner equals new scanner system.in, and then let's create int number equals n.next int. Alright, so in Java, you see these two curly brackets right here. You can actually write other methods. This is just the main method. You can write like other methods here. For example, let's create public static int. We have to give this method a name, calculations, and then we also have to create an object. So what this does is pretty much when we want to use this method, we have to use calculations, and then we have to put an integer in this spot. It can't be a string, otherwise we'll get an error. It has to be an integer. So let's put number here. Now, if this part had like string strtemp, we have to capitalize that, then we'll also get an error here. Not because this method just doesn't work. It's because we haven't added a string. We're missing out a string. So yeah, pretty much whatever's here, here's an integer string. We need to put an integer and a string in these brackets right here. So yeah, that's pretty much what methods, like what this bracket here is for Java methods. And now what we pretty much do, the public static and then int or string, boolean, whatever, you have to return a value. So here we can do like int temp is equal to number times 8, and then we will return temp. So if we do this, then we will have to print out whatever gets returned. Oh, and we are missing a semicolon right there. Alright, so let's run this program. So pretty much this returns temp times 8, and then now we have to print out whatever temp is. So let's say here number is equal to 3. It prints out 24 because 3 times 8 is equal to 24, and then we returned temp. So now calculations with number inside of it is equal to 24. And if we didn't have the system.out.println, we wouldn't get the 24. So yeah, that's what static int is. So it doesn't always have to be static int. It could be like static string or static boolean, or pretty much the type of variable you will be returning. So now we have public static void. Another method type is public static void. So here we do not return anything. We can print out some stuff here, you know. So let's say int temp equals numbers times 8, and then we print out temp right here. So if we do that, then we won't need to like write down system.out.println calculations and then number, because that's not exactly how it works. Wait, oops. Yeah, so here it says it cannot resolve method println void. It's because we've already printed out something in calculations, and now we're printing out something. So that doesn't work in Java. So instead of doing system.out.println, let's just get rid of it and a number there. Now this will work. There's no errors here. If we enter 3, we get 24 because 3 times 8 is 24. If we enter 2, we get 16. Just like that. So that's pretty much how methods work in Java. So let's change this to identifier, and then let's change this to input. I don't know. It's just for organizations. You know, here we could just do like int input is equal to n.next int, and then we print out input times 8. We could do that, but instead of like using methods and stuff like that. But actually, for organization, we're just going to be using methods because I feel like that helps the user a lot because they're not like searching through their code for if they have an error. They're not. It's like less code to search through, if you know what I mean. Okay, so public static void identifier into input. Okay, so int input here is the object. So now we want to identify if input is a prime number. So what we do here is we basically divide inputs by 2. So let's say input was 6. 6 divided by 2. Hang on. Let me add that. 6 divided by 2 is 3. And now we create a for loop. So for integer I is equal to 2, I must be smaller than whatever, smaller or equal to whatever input divided by 2 is, and then we increment I by 1. So every time we run the for loop, I increases by 1 until it is greater than half of input. So if I were to be equal to 1 in this scenario, 2 in this scenario, then 6 mode 2, so I'm going to write that down, 6 mode 2 is equal to 0. By the way, this percentage sign means mode. Mode is basically the remainder. It prints out the remainder. So 7 mode 2 is 3 remainder 1. So 7 mode 2, I don't know why I use double equal signs, but okay. 7 mode 2 is equal to 1. 6 mode 2 is equal to 0 because 6 divided by 2 is 3 remainder 0. So once we do that, if input mode I is equal to 0, then we will print out composite, and then we'll like break out. We'll just like break out the for loop. And yeah, so that's pretty much what we're going to be doing. We could just like make it so that I is smaller than input, like the integer itself, input. But once we get to half of input, it doesn't really matter because like because we already know like most of the factors, whatever the factors are. Like let's say it's 45. All right. So actually no, that's not a really good example. Let's say 72. Does that work? I don't know, but yeah, let's say we have 36 right here. So if we divide 36 by 2, we get 18. So now we just have to find the integers that are smaller than 18. And pretty much almost all of 36's factors are less than 18. So that's not a really good example. Let me think. Any good examples out there? Not that I can think of right now, but well, let's try 12, you know. No, that doesn't work. Okay, so what I'm pretty much trying to say here is that pretty much we just need to find half. So 12 is equal to 1 times 12, 2 times 6, 2 times 6, and 3 times 4. Once we just find 1, 2, and 3 and divide 12 by those numbers, then we won't need to find 12, 6, and 4 because 3 times 4 is 12, 1 times 12 is 12, 2 times 6 is also 12. So we won't have to like find out like if 12 mode that is equal to 0 because once 12 divides by 3 it is equal to 4. So yeah, it doesn't really matter. We could just like make it we could just like do the whole number itself. Like we could find 4, 6, and 12 here, but it doesn't really matter at in the end of the day. So yeah. Anyway, so let's get started by writing the for loop. So for integer I is equal to 2, I must be smaller or equal to input divided by 2, I increases by 1. Okay, so now we have to write an if statement. If if input mode I is equal to 0, we print out composite, we break out of the for loop. Now, how do we print prime? Because like, if we were hasty, we would just do system.out.println prime. But the thing is, let's say input were to be equal to 9. If input was 9, then we do 9 mode I, which is 2, which isn't equal to 0. So we just jump to else. So else we will print out prime. But we know that 9 is 3 times 3 and it's composite, so we can't do that. So here we're gonna be creating a boolean. A boolean is another variable. It can hold 2 values, yes or no, true or false. So let's say boolean is prime is equal, let's set the value to true. If it is equal to composite, then is prime, is now equal to false. And once we exit this for loop, we will say if is prime is equal to true. Because if it remains true, it has not ran through this if statement yet. So it actually is prime. So if is prime is equal to true, then we will print out composite. Now there's a few exceptions to this case. Oh wait, sorry, not composite. Prime, we will print out prime. So there's a few exceptions to what input can be. So what I'm thinking here is if input is equal to 0, then we will just terminate the program. So if input is equal to 0, system dot exit 0. So that's what we do if we want to terminate the program. Also, if input is smaller than 0, smaller than 0, then we will print out composite, because anything smaller than input must be anything smaller than 0, so like it has to be negative. Anything that's negative must be composite. So system.out.println composite. Now there's also another case. Input is equal to 1. So here, prime numbers are pretty much itself multiplied by 1. But if 1 is equal to 1 multiplied by itself, which is 1, then it only has one factor. So it technically isn't prime or composite. So we'll print out is not prime or composite. Alright, so that's what's going to happen here. And yeah, so now we have int input equals n.nextInt. My idea here is we first create int temp, which is a temporary variable. Let's set it to 100. So while temp isn't equal to 0, and now we get input, because input equals n.nextInt. Temp is equal to the value of input. If temp isn't equal to 0. So you might be wondering why I am writing this if statement right now, because doesn't this while loop do everything? No. If temp is set to the value of input, the program will continue running. Oh, sorry, that should be equal. So the program will continue running until it finishes like one time in the while loop. And once it returns to the top and sees that temp is equal to 0, then it will break out of the for loop and continue on. So that's not how it works. Well, that is how it works, but like we don't want that. So we're writing this if statement. So if temp isn't equal to 0, then we do identifier input and then else we terminate the program. Oh, oops. Alright, so that should be it. And I'm just gonna add some greetings at the top, because why not? I'll say welcome to the prime number identifier. I should capitalize these. Prime number identifier, and now you do please enter a number. Please enter a number. Enter 0 if you want to quit. Now, here we will be printing exiting, because we are now officially exiting the program. And I am going to go to the top and change our identifier function. So where is it? Yeah, we also have to add exiting right here. I don't know why, but okay, alright. Probably, yeah, this part is just unnecessary. It's unnecessary code. The code in the identifier method solves it all. So yeah. Alright, so let's run this program. Let's enter 0 first, exiting. Yeah, so that's how it works. I feel like we should do exiting ... Okay, alright, 1. Bam. Oh, okay, never mind. Let's see what happens now. It is not, okay, so it just jumps to that. So we have to make is prime equal to false for all of these cases. So it won't just like jump. So then it won't jump to this if statement right here. Alright, let's run this again. The 0 works. Let's check out if 1 works. Alright, 1 not prime. Alright, -1 composite. Yeah, that's it. 2 prime. 3 prime. 121 composite, because it's 11 times 11. And yeah, this is pretty much it. 0 exiting. Awesome. So yeah, this is it. This is the prime number identifier. I hope you enjoyed this video. And yeah, I'll see you in the next video. Goodbye.